Hello everyone, welcome to Lab Automation and HTS Academy. Today we are going to talk about the liquid handling robots and how they can make our life easier in the lab. Almost all of the chemical and biological reaction happened in the liquid format. Liquid can be in different containers. It can be in the test tubes, epender of tubes, and in microplates. Microplates can have 6, 12, 24, 96, 384, and even 1536 wells. As a result, we need a tool to be able to transfer different amount of the volume, different amount of volume of the liquid accurately from one location to another. We do so mostly by using pipettes. Pipette can have single or multi-channels. We have 9 or 12 micro-channel pipettes. And for each volume range, you probably would need one set of the pipette. For example, if you are transferring liquid less than 10 microliter, you need a different pipette compared to when you are transferring 800 microliter. Pipettes are very powerful tools, and they are very handy. But what if you had 100 or even thousands of the samples? At that case, the whole process can be very laborious, and also it can be very prone to error. It's very easy to make error. If you work with the pipette before, especially when you are working with like a 96 or even 384 well plates, microplates, you will see that it's very easy to make mistakes. That's just the nature of it. It's just like you're human. We cannot do very complex procedure. It's just, we make mistakes. That's the longest story short, we make mistakes. So what can we do? Well, the good news is, at least for this case, we have a tool. And that tool called liquid handling robots. Liquid handling robots can have different channels. For example, we have a head with 8 channels that is on the left, and this can interact with different type of the container. It can work with the epender of tube, test tubes, different microplates format. And it's very flexible. You can transfer from 0.5 microliter of the liquid to 1 ml using the same channel. And we also have different type of the liquid handler that you can go even in nanoliter type of the application. We can also have a 96 head on the robot. And the 96 channels, you can transfer the entire 96 well microplates in one aspiration. Or you can convert 496 into a 1384 well. We even have the head that are compatible. We also have the 384 well heads that you can transfer the entire 384 well samples into another plate. So you can see that is very powerful. You can do lots of things. And of course, it comes with a limitation. For example, when you're using a 96 well head, you cannot just control each single channel. All of them going to transfer the same amount of volume at the same time. So that power is coming with the compromising the flexibility a little bit. But for most routine cases, when we are transferring the liquid, that is exactly what we want. We will just want to do transferring the liquid from one location to another. And even there are new liquid handlers that they don't touch the liquid and they still transfer the liquid. For example, I have an Eco 525 here that is using the SOND technology to transfer the liquid without even touching the liquid. That's amazing, right? I mean, it's a new dimension of doing experiment. So where did liquid handling robots come from? You guys are probably not here for a history class, but in case you're interested, I have this link, and I would put it in the description so you can click on it and read more about the history of the liquid handling. But the modern liquid handling, everything started in 1970 when the company called Hamilton started developing mechanized pipettes. And what they did, They pretty much mixed a DC motor with the precise syringe, and they commercialized it as a digital diluter, and that was 1971. After that, they continue growing and making new products. They collaborated with another company called Tecan, and they commercialized Hamilton Amica system in 1980. And that was at the time a revolution. But these days you would see that we can do much, much more. But everything started with this idea to mechanize the whole pipetting process. If you're interested, guys, I will put this link into the description so you can go and read more about the history. And I'm going to actually touch more about this when I'm covering the Hamilton robots in the future. I will talk more about the history of the Hamilton. I think it's very important to talk about it because it's a sort of a godfather of the liquid handling and lab automation. So we need to know a little bit about the history and where it comes from. Okay, then they call liquid handling robot. So we expected that they just transfer liquid from one place to another. But in reality, these days, liquid handling robots are like a heart of a platform, a workflow. You can integrate a liquid handling robot with different tools. For example, here on this picture, we have a plate incubator, we probably have some plate washer, and we have a microplate reader, all of them being integrated with the liquid handling. So you can do the whole workflow from diluting your sample, transferring the samples, to wash the plate, to read the plate, all in one station. And that is actually what makes the liquid handling robots very important, because these days they are like the heart of the system, the heart of the automation workflow. It's very hard to put all of the liquid handling in one basket. So I got this image from this paper. I will put the link of this paper also in the description. If you're interested, go ahead and read it. But the whole idea here is that we can roughly classify the liquid handler that we these days see in the lab into like 4 different categories. On the far left, we have the manual pipettes. Yes, you can use them for limited number of the samples, and that is something that we do all the time in the lab. Then we can go one step ahead and just have a sort of single channel liquid handler. They are still very handy, they are very helpful, and you would see some of them in the lab. There are some examples that you can see on the screen. Then you can go also one step ahead, and you're talking about less expensive robot here, for example, OpenTron. And all of these are based on the DIY workstation and mostly are based on the open source program. These are good when you want to do a limited function. For example, you just want to prepare your PCR plate. These robots can be handy. They are less expensive compared to other robots, but of course you can do less with them. So that's something to have in mind. If we go one step further, we can find some sort of a specialized liquid handling or liquid handling station. For example, Agilent Bravo, that has been optimized for the NGS workflow. That is something that you can use to just do several steps of mixing, aspiration, dispensation, going from one plate format to other, and all sort of those stuff. And the most complicated and sophisticated liquid handling that we have, you can do much more. You can integrate your liquid handler with plate reader, plate washer. You can integrate 2 liquid handlers together. For example, and the best cases of this type of the liquid handler, or best known type of this liquid handler, are the Hamilton Microlab Star and the Tecan Fluent. And I'm actually going to cover those 2 in future videos in this channel. So if you are interested to learn more about those, remember to subscribe to this channel. So let's continue. So now that we have this many options, and probably every day you can see a new liquid handler come to the market. So how you make decision, which liquid handler is the best for your application? That's actually a kind of hard question, but I would say that it's highly depend on your budget and application. I try to summarize a few factors that you need to consider when you want to purchase a new liquid handler or when you want to upgrade the one that you have. So the first is the price. Back to the previous slide, when you go from the left to right, it's become more and more expensive. So the price is something that you need to keep in mind. And of course, with the price comes, features. If the throughput is what you are looking for example, you want to process 10 samples a day, you want to process 100 samples a day, or you want to process 10,000 samples a day, you want to use your robot 2 hours a day, or you want to use it 24/7. All of those become important when you want to design your process. One factor is the deck size. How many of these microplates you can fit on your robot? How many tips you can fit on your robot? Those are all important factors because those are dictating your throughput, how many samples you can process. And the other parameter here is the pipetting speed and capacities. Again, not all of the liquid handling robots are using the same mechanism to transfer the liquid. Some of them are faster, some of them are slower. Are you going to use the 96 microplates or you are going to only use tubes? Those are together, right? There's like a type of the trade-off that what you want to do with your robot. The other factor that become practically very important is the availability of the service and the consumables. These robots, all of them, they have their own consumables. The tips that you can use on a Tecan, you cannot use it for the Hamilton. You have to purchase the tips for the Hamilton. And also the service. These robots, they are pretty robust, but there are many cases that you would need somebody, engineer or somebody from the company come and fix your robot. You have to check if that service is available in your location. And the other factor is, okay, if I want to do a whole workflow, for example, I want to do the whole PCR, RT-PCR workflow, or like a COVID testing on the same robot, then you have to answer the question, is it compatible for the integration? What that means is you want to check if the modules, those devices, those instruments exist for that platform. These instruments, devices are usually built by third-party companies. And these third-party companies, they don't build it for all robots. They just build it for the best seller. So that's something that you need to remember. And also the API, these devices, these instruments, they talk to each other. And they talk to each other through an API. So that is very important to understand that can my robot communicate with the PCR machine that I'm going to purchase or no? So all of them back again into your workflow, the process that you want to design. Based on the process, you can answer these questions. The other factor that I find is really important, and you may not think so, but is the expertise availabilities. Some of these robots, some of this platform, they have a very steep learning curve compared to the others. Some of them are very easy to learn and master. So you need to answer, what's your approach? Do you want to hire an automation engineer to be in your site all the time when running the robot? Or you want to train one of your wet lab scientists to operate the robot? That's actually become very important. Just based on my experience, I can say that this is probably one of the most important factors. Have it in mind. So what you want to do, who is going to run this robot? And do you want to spend money and hire a new person to do it? One of your wet lab scientists is going to go to training to learn how to use it. Those sort of questions become very important down the road. And then we have the flexibility. What that means, for some application, for example, you are working in the testing lab. So you are going to run the same assay probably 24/7 on the same robot. So flexibility probably is not that important for you. You program the robot, you test it, and then you run it 100,000 times. So flexibility is not the case for you. But if you are working in a small lab and you have a limited budget, you cannot purchase the robot for each workflow. You want to have one robot and use it for 10, 12 different assays. And that's actually my first job was like that. I had to reprogram the robot for like different assay every month or every 2 months. So then flexibility is important. And I get to this point when we talk about the Hamilton and Tecan in the future. But that is also something important. Are you working in the testing lab? You are going to do the routine testing, or no, you want to just quickly redesign and reprogram your robot to do different assays. And the other factor that's probably very obvious is the volume range. What kind of the volume you're going to work? I talk about the different type of the channel that you can have on the robot, but there's a limitation. Usually for most of the liquid handler these days, the minimum volume that you can go is 0.5 microliter. And the max that you can go is 1 ml or 5 ml. And that also can dictate the price that you pay for the robot. And also it can limit your flexibility of a robot. For example, ecosystems, you can go to the nanoliter volume. But the problem would be it's less flexible and you only can use certain consumables that are available by that company. So that is also important, but I think it's obvious because volume is the first thing that people usually think when they design the assay. And finally, accuracy and robustness. So the whole purpose of one of the main reasons people use the liquid handling robot is to make the whole workflow more accurate and more robust. People can get tired, they can make mistakes, but robot, theoretically, they don't get tired, they don't make mistakes, or at least that is what we hope. And you would see differences between different liquid handling robots based on the accuracy and robustness. And the main reason is because they are using different mechanism, different mode to transfer liquid, to pipette the liquid. Not all of them using the same syringes and same mechanism. And each of those companies have hundreds of the patents on the mode of the transfer, the liquid transfer that the mechanism that they use. And again, we're back to the first point, that is the price. Usually, and just like a rule of thumb, the more expensive robot, they are more accurate and they are more robust. But you will see that that's not the case all the time, but that's something just keep in mind. Okay, so we talked about a few factors that you need to consider when you are purchasing a liquid handler for your lab. And at the end of the day, everything boils down to how much money do you have and what you want to do with your robot. If you answer those two questions, you probably can find a liquid handler that can help you to make your life easier in the lab. But the two most common companies that you probably see in 90% of the labs are the Hamilton and the Tecan. And these two companies are the pioneers, the companies that actually created the modern liquid handler robots in the first place. Hamilton and Tecan, they have different line of the products. And again, they back to how many, for example, what's the size of the eaches, how many head do you have? And that's again back to what you want to do. For example, for the Hamilton, we have a smaller system called Nimbus. And that is good for like shorter workflow or a smaller procedure that you want to automate. For example, you want to automate your DNA extraction. So that probably needs like just a few steps and you can easily do it on the smaller liquid handler. Or no, you want to have more flexibility, more freedom to do stuff. Then you can go and use, for example, a Star. And if you think of a process, a workflow that you can integrate different devices on the same robot, then you probably need to go and think about purchasing a Vantage. And they become just more and more expensive from a smaller people. For the Tecan, we have different counterparts. For example, the counterparts for the Star in the Tecan world is the Evo Freedom. And for the Vantage, we have Fluent. I'm going to talk about these two more in this channel, I'm going to talk about the software of the Hamilton, and we are going to go through, I'm going to teach you how to use the software on the Hamilton and on the Tecan. So just stay tuned if these are the liquid handlers that you're going to use. But as I mentioned, there are hundreds of the liquid handling robots that you can find. Just Google it. Just Google liquid handling robots, and you probably would see 100, each with different, flexibilities, throughput, speed, and so on. So at the end of the day, you want remember that you want to answer this question, and all robots are developed to answer one of these needs. Okay, guys, that was the first video that for this channel. If you have any suggestion, if you want to see a certain topics in this channel, or you want to collaborate, I honestly have limited time and expertise to cover in this channel. If you are familiar with a certain machine or software that you think that's going to be useful for the community, please feel free to reach out. And if you need my help for designing your workflow, picking the right liquid handler, and so on, don't hesitate to contact me at the email that I have on this slide. I will put this email into the description too. So guys, happy automating, and see you next time.